Welcome. Today we'll learn about nerve impulses and why a second nerve impulse can only be generated after the resting membrane potential has been reestablished. Let's start by visualizing a neuron membrane at rest. Here we have the cell membrane with sodium and potassium ions on both sides. At rest, there are more sodium ions outside the cell and more potassium ions inside. At rest, the inside of the cell is negatively charged compared to the outside, creating a resting membrane potential of about negative 70 millivolts. When a nerve impulse occurs, the membrane becomes temporarily depolarized. Sodium channels open, allowing sodium ions to rush into the cell. After the impulse, the membrane enters what's called the refractory period. During this time, the sodium-potassium pump works to restore the original ion concentrations, and the membrane potential gradually returns to its resting state. This is why a second nerve impulse cannot be generated until the resting membrane potential is reestablished. The neuron needs to, first, restore the proper ion concentrations. Second, reset all ion channels. And third, reestablish the negative resting potential. Think of it like recharging a battery. You can't use the energy again until the battery has been fully recharged. Similarly, a neuron needs to fully reset before it can generate another action potential. Understanding this refractory period is crucial in neuroscience, as it determines the maximum frequency at which neurons can fire and helps prevent overstimulation of the nervous system.